Presenting the Simnovus UE Simulator for the validation of non-terrestrial networks. In contrast to a terrestrial network, non-terrestrial networks comprise two additional components, satellite and satellite gateways. The satellite, which lies way above the ground, introduces a significant delay in the propagation of the signals. Let us see how Simnovus UE Simulator can help validate the new features introduced in 3GPP Release 17. To begin the test, we create a test case. The configurations are the same except for a few newly introduced fields. Enable the NTN field while defining the cell. When enabling this, the option to enable carrier aggregation and mobility disappears, as these are not supported. Next, let's configure the subscribers. Set the value of -1 in the field named NTA so that the UE automatically calculates the timing advance required to compensate for the delay between the UE and the base station. The delay will vary based on the UE's position and the satellite's position. So, let us go ahead and define the position of the UEs on the ground by providing the latitude, longitude, and altitude. Since NTN is a Release 17 feature, let us set the axis stratum release to 17. Now, let's configure the UEs to perform bidirectional UDP traffic. Set the destination IP address, the uplink, and the downlink bitrate. End the configuration of the test case by setting the log level and giving it a name. Alright, now that the test has been executed, let us analyze the logs. The base station sent the SIB1 message, which indicates the support of NTN and the use of SIB19. The timers, such as T300, T311, etc., are set to higher values. Let's now look at the SIB19 message. The SIB19 contains the K offset, TA common, and the ephemeris data. Satellites and NTNs move constantly in their orbits. Without ephemeris data, the UE wouldn't know the precise location of the satellites it needs to communicate with. The received signal also experiences a Doppler shift due to the relative motion between the UE and the satellite, affecting its frequency. The ephemeris data allows the UE to predict this shift and compensate for it, ensuring accurate decoding of the received information. After receiving this information, the UE performs the random access procedure. The network assigns it the timing advance TA in the RAR. Let's look at each of these messages. Let's filter the RRC layer messages only to make it easier to find the specific message we want to look at. Let us now look at the UE capability information message, where the UE informs the network that it supports NTN. In addition to the measurement and mobility parameters, we see that the UE reports that it supports disabling the HARQ feedback. Until the next video with more, please keep watching our videos and subscribe to our channel for more updates.